Question number 1. We are given fx x to the power 4 3x cube x plus b. A and b are constants. B a polynomial function. When fx is divided by x squared plus x minus 1, the remainder is 2x plus 3. Find the values of a and b. Right. This time we have to divide this polynomial function fx by this given device x squared plus x minus 1 using log division method. Log division method. We have to divide. Okay. Right. Let's say how to divide this x4 plus 3x cube plus ax plus b should be divided by the divisor x squared plus x minus 1. First is x4, we divide by x squared, we get x squared. By x squared we multiply all these three terms and right below this, then we get x4 x cube minus x squared. Now subtract this, then x4 minus x4 0, 3x cube minus x cube 2x cube, and here this will be plus x squared and ax plus b, right? Now this is divided by, again, this 2x cube we divide by this x squared, then we get plus 2x, no? This 2x cube we divide by x squared, plus 2x coming. 2x and this 3 we multiply. 2x cube plus 2x squared minus 2x. Now subtract this minus this. Here we get minus x squared. Here we get a plus 2 times x and b. Okay. Then finally we divide this minus x squared by x squared. We get minus 1. By multiplying this minus 1, we get minus x squared minus x plus 1. Then subtract this and this. Here we get a plus 2 plus 1 times x, right? And b minus 1. So here the degree is 1. Here of the degree divisor 2. So therefore we don't divide furthermore. Right? Now we have finished dividing this. Now we are given the remainder is 2x plus 3. So therefore this is remainder. Remainder here we get a plus 3x. Here 2 plus 1 is 3. A plus 3x. B minus 1. This is the remainder. We are given this remainder is equal to 2x plus 3. 2x plus 3. So then we can equate the coefficients of x here. A plus 3 is equal to 2. That gives a is minus 1. And secondly, b minus 1 is equal to 3. B equals 4. This way we can take a minus 1 and b 4 is the answer. Right, no? Yeah. Second one, we can take limit question. Limit x going to 5. All right, root 2 plus cos 6 minus 1 divided by 5 minus 6 perfect square. First we multiply both this numerator and denominator by the conjugate of this numerator, right? Conjugate of this numerator. Then conjugate of this numerator going to be this plus 1. Then that takes the form x minus y into x plus y. I can then write this one this way, no? Minus 1, its conjugate is this. 2 plus cos 6 plus 1. 5 minus 6 perfect squared and here 2 plus cos 6 plus 1 this way, right? Limit x going to 5. Here, this is like x minus y into x plus y. That you can write as x squared minus y squared. So, then square of this, the root will eliminate, minus 1 squared minus 1. Then we get 2 plus cos 6 minus 1. That means 1 plus cos 6. 1 plus cos 6 divided by 5 minus 6 perfect squared. And here we have 2 plus cos 6 root plus 1. Now we'll apply limit separately to this, separately like this, and limit x going to 5. Right now, we can write this cos 6 using half angle formula. Right? 1 plus cos 6 we can write using half angle formula. There are people this way, limit x going to pi 1 plus, this one you can write as 2 cos squared x by 2 minus 1. That way you can write this cos 6 using half angle formula. I minus x perfect squared, and this part, limit x going to pi 1 over, right, root 2 plus cos 6 plus 1 this way. These two you can cancel. Right, now little rearrangement here we have to do. Limit x going to pi, this cos 6 by 2 I can write sin 5 by 2 minus 6 by 2. You know, sin 90 minus theta is cos theta. Then sin 5 by 2 minus 6 by 2 is cos 6 by 2. Right. This 2 I write before here. And here we have square. Then this one people 5 minus 6 perfect squared also. No? So there I write this way. 5 minus 6. I write here 2. Then I am going to square this whole. Right. Then really this is cos 6 by 2. After squaring that we get cos squared x by 2. This is coming without any trouble. And here we get really 5 minus 6 perfect squared. Here divided by 4. Extra 4 is coming. That 4, to cancel down that 4, I write 4 here. That 4 I take out and write here like this. Correct, no? Right. Now, really, this thing 5 minus 6 divided by 2, I can write 5 by 2 minus x by 2. Right? The same angle, therefore, we get. And limit, here x going to pi, we have 1 upon, right, root 2 plus cos 6 plus 1. 2 plus cos 6 plus 1 this way, right? Right. It's okay. Then here we have half. Take that half out. Limit x going to pi. This one I can write sin pi by 2 minus x by 2 divided by pi by 2 minus x by 2. Perfect squared. And shall I put this x going to pi here? When I put here pi, cos pi, right? Cos pi means cos 180. Cos 180 is minus 1. 2 minus 1 is 1. Root 1 is 1. 1 plus 1 is here 2. We get 1 over 2 here. Right. We get 1 over 2 here. So now you can simplify there, people. Right. The answer. You know this is sin theta by theta. When x going to pi means, here, x going to pi means x by 2 and pi by 2. X by 2 going to pi by 2. Right. So then it is of the form sin theta by theta. That is therefore 1. Therefore this is 1 squared. 1. Here half, there half. We get therefore 1 over 4. 1 over 4 is the answer. Right. Third question, number 3. Yeah. The parametric equation of the curve C is given by x equals 6 cos 2t, y equals 2 sin t. Here t in between minus 90 and plus 90. So that dy by dx is lambda cosec t, where lambda is a constant to be determined. Right. Okay. We'll write that. Number 3. Given the parametric equation of the curve C, right? I take the curve C like this for instance. This is the curve C. Its parametric equation given by x equals 6 cos 2t, y equals 2 sin t. Right. We can write dx over dt. Right. Cos 2t derivative, when we take with respect to t, it's minus sin 2t into 2. Cos 2t derivative, cos derivative minus sin. No? And then we get dx over dt minus 12 sin 2t. dy by dt will take 2 cos t, sin t is cos t. Then we can write dy by dx by using the chain rule, dy by dt into dt over dx like this. Then dy by dx we can write dy over dt going to be 2 cos t, 2 cos t. dt over dx means, people, the reciprocal of this 1 over minus 12 sin 2t. Right. Then we can write, simplifying this, this 2 and this we can cancel down. We get dy by dx equals minus 1 upon 6 cos t. I can write divided by sin 2t. I can write 2 sin t cos t. This 2 we can cancel down. Here we get minus 1 over 12. 1 over sin t is cosec t. No? Cosec t. This is our dy by dx. Now asking to write this dy by dx lambda cosec t. Lambda cosec t. Asking to write this dy by dx as lambda times cosec t. So this lambda going to be this answer. Therefore, lambda equals 1 upon 12. Correct. Right. Find the equation of the perpendicular drawn to the curve C at t equals pi by 6. Then dy by dx is the gradient, no? Right. Then we need to find at t equals pi by 6, right, the coordinates of the point, x coordinate and y coordinate. For that, this t equals pi by 6 we put here and here. Then we get x and y coordinates of that point. X equals 6 cos, right, t 30 2 into 30, 60, 6 cos 60. Right, that gives us x equals cos 60 half 3. Right. Then what is y? Y is 2 sin 30. Sin 30 is half. We can cancel down. Y equals 1. Then we get x point is 3 comma 1. Okay. Now we'll find the gradient dy by dx. dy by dx at t equals pi by 6. To find that, put that 30 here. Minus 1 over 12 cosec 30. Cosec means 1 over sine, no? Sine 30. Then we know 1 over 12. People sine 30 is half. Then we can cancel down these two with this. We get 6. Then we get minus 1 over 6. Right. Then here, this dy by dx means the gradient of the tangent. Gradient of the tangent. But we need to find the equation of the perpendicular. No? The perpendicular, its gradient can be obtained. How? Taking the reciprocal and multiplying this by negative sign. Right? So that gives us the gradient of the perpendicular. Right? Then gradient of the perpendicular. Right? Going to be what? Is take reciprocal and multiply by minus m6. Then we can use y minus y naught equals m times x minus x naught formula. Y minus y naught means the y coordinate of that point, it's 1. Gradient now 6, x minus x naught is 3. Then we get y here minus 6x, here minus 18, plus 18, 17. This is that equation. This is that equation, right? Okay. Right, fourth one, people, number 4. Fourth one, we are given find the equation of a line which makes an angle 45 with the line this and passing through the point 3, 2. Yeah, here people, we are given a line. Its equation is given as x minus 2y equals 3. Then if I take that 3 to left hand side, minus 3 equals 0, we get. Then you can find the gradient of this line. The gradient going to be, when you subject y, take this side and divide by 2. Then we get the gradient as half. Here the gradient of this is half. Okay, gradient is half. Okay, right. And the line we need should be making 45 degrees with this line, and that should also pass in through the 3, 2. Right. Then this is how people, the two lines we need. This is the one line that makes 45 degree, right? And other line, people, should be like this. These two red lines only we need to find. This red line also making angle 45 with the black line. Right, both the red lines passing through where? 3, 2 point. This point is 3, 2. Okay, correct, no? Okay, now we need to find the gradient of these red lines. Gradient of the red line. I'll take the gradient of one line here as m. Then between this red line and the black line, the angle is 45. You know the formula. The tan of the acute angle between two lines. So that is given by this formula, no? Tan theta. In the straight line lesson we learned m1 minus m2 divided by 1 plus m1 m2. By using this formula, our theta is now 45. M1 suppose this m, m2 suppose that half. Then we can calculate two answers for m, right? We get two answers for m because there are two such lines. Okay. Now we'll take that. Right. So then substitute for theta 45. Tan 45 equals m1, I take m minus half divided by 1 plus m by 2, m1, m2. Right, this is 1, no? Then we can eliminate these people modulus, putting to this side plus or minus m minus half divided by 1 plus m by 2. Correct, no? Right, so then solving this, we get two answers for m. Let's see what are the two answers. First, we'll take this plus sign and use the cross multiplication to this end. 1 plus m by 2, m minus half. Take this side, then we get 3 by 2 is equal to m minus m by 2 is m by 2, no? Then we get m is 3, first answer. Okay. And the second answer we can take by minus sign. Minus sign, when you take here, we get minus 1. Then use the cross multiplication to this end. Minus 1 minus m by 2 and minus m minus half. Right. Then there we get, take this to this side, then minus 1 plus half is minus half. Okay. Take this side, m plus m by 2, 3m by 2. Right. Okay. So then these two can cancel down. M should be minus 1/3. That's fine, because you know, people, this red line, if this makes an angle 45 with the black one, this also making 45 with the black one, the angle between these two red lines should be 90. They are perpendicular. Then the gradient should be, right, the product of gradient should be minus 1. Right, that's coming, no? Yeah, now that's only. Now this two red lines passing through 3, 2, no? That we can take as x0, y0. As before, using this, you can find the two equations. They are for the equations. They are for the equations. First one, y minus, as our y0 we can take 2. First gradient we will take as 3, x minus 3. Second one, y minus 2 minus 1/3 x minus 3. This way we can take the two equations, right? So this one gives us y 3x to left hand side minus 3x minus 9 plus 9 minus 2, 7. So 0. Here we get 3y, right? And minus x when you take this side plus 6. Here minus 6 minus plus 3 plus 3 when you take this side minus 3 minus 9. These are the two equations of the required lines. Right. Right, people, next one. Number 5. Question number 5. Now 5 given trigonometric tan inverse, inverse trigonometric equation given 1 over tan inverse 1 over x minus 1, right? Tan inverse minus tan inverse 1 over x plus 1 equal to tan inverse half. X positive and x not equal to plus or minus 1. We are given x positive, no? X positive, x not equal to plus or minus 1. Right. Okay, no? Now, we will take this angle as alpha. This angle as beta. This angle will take as gamma. Alpha equals tan inverse. This means tan alpha 1 over x minus 1. Tan beta 1 over x plus 1. Tan gamma half. Then we can write the given equation as alpha minus beta equals gamma. This way you can write the given equation. Right. Then we can take tan on both sides. Take in tan. Take in tan on both sides. We get tan alpha minus beta equals tan gamma tan alpha minus tan beta divided by 1 plus tan alpha tan beta equals tan gamma. Right. Then substitute for tan alpha tan beta and tan gamma, and when simplify this. Tan alpha 1 over x minus 1, tan beta 1 over x plus 1, 1 plus the product of these two, 1 over x squared minus 1 equals tan gamma, it's half. Correct, no? Here, these two, the product only we must write there. 1 over x minus 1 into 1 over x plus 1 is 1 over x squared minus 1. That we get. Now we'll simplify this furthermore. Right. So when you simplify that, people will take common denominator here, the product of these two, then x plus 1 comes here, x minus 1 comes here, the denominator going to be x squared minus 1. At denominator also we take x squared minus 1 as the common denominator, then that x squared minus 1 comes here, then the numerator, denominator and denominator we can cancel down. Then we get x plus 1 minus x minus 1 divided by x squared plus x squared minus 1 plus 1 like this. Right. And here we have half. There you can cancel down this and this. This is 2 really. Here x squared. Here 1 half. Bring here 4 equals x squared. X is plus or minus 2. Right? X greater than 0 given. Then minus n you can take. Therefore, x equals 2. Answer is x equals 2. Right. Next one, question number 6. Next one, question number 6. Right, question number 6. Let's say we have inclined plane. It makes an angle alpha with the horizontal. Particle is projected with velocity u from a point A. perpendicular to the plane. Right. If the particle hits on the plane at the point B, show that AB this. No? It moves this way, right? It is B. Right. Now, if I draw here, people, the G, acceleration due to gravity. This point is A. That acceleration due to gravity I can resolve in two components this way. One is perpendicular to the plane, other one is along the plane this way. Okay, then you know if this is alpha, this is 90 minus alpha, this is alpha, then this way we have the component G cos alpha, this is G sin alpha. Now we apply for the particle S equals ut plus half a t squared for the motion from A to B perpendicular to this plane. Okay, you can now write for the motion from A to B, we apply S equals ut plus half at squared this direction perpendicular to the plane. Right. Then the motion displacement of the particle perpendicular plane is 0. You know, when we consider this way, this is a ground. Suppose particle is projected with initial velocity u. Particle comes back to the ground again. Then, when we apply S equals ut plus half t squared, right, for this motion perpendicular to the ground, upwards like this, we know this S becomes 0. People, now the same thing, everything, right? Suppose we incline to an angle alpha with the horizontal, suppose the whole ground we incline this way, then still the same thing is true. Now we apply S equals ut plus half t squared, again perpendicular to the ground. The ground now has turned through an angle alpha. The same situation is this. That is why we say here perpendicular to the plane, the displacement of the particle is 0. So therefore, we get S0 in the perpendicular direction, velocity is u t plus half. Here A along this direction. You know, people, along this direction, acceleration is pointing this direction, g cos alpha. Therefore, that is minus g cos alpha times t squared. 1 t you can cancel down. Then you can subject t. Takes this side. We get plus multiply by 2 both sides, 2u. Takes this side. T divided by g cos alpha. U over t cos alpha is the t. Then we need to find this AB distance. Now we apply S equals ut plus half t squared along this plane down. Take that. Now we apply S equals ut plus half at squared this direction for the same motion AB. Then the displacement along the plane going to be AB. Initial velocity along the plane down no velocity, people, because it is perpendicular to the plane. U cos 90, 0. This is 0. Half G. This A, it is G sine alpha. T squared, T is the time this. For U squared divided by G squared cos squared alpha. This we get. Right, now I will simplify this. 2 and this 4 we can cancel down. 1G we can cancel with this. Right? Then we get 2U squared. Right? 1 cos alpha we can take with the sine alpha, sine by cos tan. Other cos alpha denominator 1 over cos alpha 6. 2U squared tan alpha into 6 alpha. We get that answer. Right, next one. Given this say, as shown in the adjacent figure, the system is raised from rest. Initially, if the particle B is at height 3 meters above the ground, find the total height ascended by the movable pulley A. Movable pulley A. Right. Okay, let's see what happens there. Clearly, here if I draw this diagram, right here this is A, mass capital M. This is B, 2m. Initially, this B is at a height 3 meters above the ground. What happens is, people, this heavier particle is B that moves down. This moves up, right? Then one occasion, this B moves downward direction, right, and comes to the ground after traveling a distance 3 meters down. Right, that occasion, this is moving upwards direction. At the moment this comes to the ground and hits with the ground, okay, the motion of this B, right, disturbed by that collision. Then suddenly the spring slacks. That occasion, the A moving upwards with certain velocity. What happens is, once the B hits on the ground, the spring slack, no longer for this particle and this particle tension neck, tension suddenly become 0. But at that moment, this A particle was moving upwards with certain velocity. Using the initial velocity as that, this particle A moves under gravity until its velocity becomes 0. Then it rises another height under gravity. That height, thus, until the particle B hits on the ground, it moves another height upwards. The total is the height ascended by the particle A. Then here, first when we mark the forces, here 2 mg, tension is T here, tension T here, tension T here, tension T here, here T. This is mg. In this case, you can see, we can really prove mathematically the distance B moves, suppose for instance, B moves downward, suppose 1 meter in a certain time interval. Then A moves upwards during the same time interval, half of that. The reason these two portions of strings available on either side of the particle A, right? So once this particle A goes upwards by 1 meter, then this portion should have 1 meter, this portion should have 1 meter, then totally 2 meters. Then this should go down 2 meters for this to go up 1 meter. That is how we simply argue it. So therefore, we can take the relation in this case. If the acceleration of this is if acceleration this upwards if by 2. If this moves during a time interval certain displacement s, during the same time interval this moves s by 2. After certain time the velocity of this is v. After the same time the velocity of this is going to be half of that, right? So therefore, all the things, acceleration, velocity, displacement of this is half of this v. Understand? That we can really prove mathematically. We can prove in the theory classes. We proved that. Okay. Now we can write the equations first to find what the acceleration and the velocity, right? Okay. Now I take the acceleration of this as if acceleration I take as if downward. Then here the acceleration is f by 2 upwards, right? One occasion if you find the velocity of this is, if this is v, this is v by 2. Okay, right. Now we'll write first the equations. Right, now we can apply F equals ma. We can write F equals ma for capital V downwards. It is 2 mg minus t equals 2 mf number 1. Number 2 for capital A upwards 2t minus capital Mg equals m times f by 2 number 2. Correct, no? Then multiplying number 1 by 2 and adding that with number 2. Multiply this by 2 minus 2t, 2t. We can cancel now. Here 4 mg minus mg, 3 mg. First one we multiply by 2. 4 mg minus mg, 3 mg. Right. Here 4 mf. Right. We multiply this by 2, no? 4 mf and this mf by 2. Okay. Then we get m, you can cancel down there. Here we get 8f plus f, 9f by 2, 3g. This and this we can cancel down. Simple f going to be 2g by 3. Right. Right. Now, people, we will find the velocity, the particle p when it comes to the ground. Okay. Initially that starts from rest. No, the system is released from rest. So now we can find its velocity by applying equation of motion. Right. Now v squared equals u squared plus 2a is, we can apply downward. I'm going to find initially it was at the height 3 meters above the ground. No, then that should move 3 meters just before hitting on the ground. Then I am going to find its velocity v squared. Initial velocity is 0, 2. Acceleration is equal to 2g by 3. And displacement is 3 meters. This we can cancel down. We get 2 root g is the velocity. Okay. Now, by this moment, right? By this moment, okay. Now the question asking, find the total height ascended by the movable pulley A. Movable pulley A. People, initially we are given this A and B are on the same level in the diagram. Look at the diagram, right? But I have drawn here not the initial position. I have drawn after starting the motion, a certain time interval t has passed. That is why they are not in the same level. Initially, according to diagram, people, you can see both the particles A and B at the same level, height 3 meters above the ground. Now I am going to find, once this B hits on the ground, it has moved 3 meters now. Then from the initial level, 3 meters above the ground, by the particle B hit the ground, A has moved up 3 by 2 meters. 3 by 2 meters. Now, it will have the velocity v by 2. Now, we are going to find, with that v by 2 velocity, what height this A can move under gravity. That height plus 3 by 2 plus 3, we have to what? Add to find total height ascended by the particle A. Right. Now, we can apply, now for capital A, we can apply upwards direction, v squared equals u squared plus 2as. We know once the particle reaches the highest point under gravity, its final velocity is 0. Here 0. That begins the velocity with v by 2. V by 2. V is this. Then v by 2 means root g. Root g perfect square plus 2 times people what? A minus g, and here I'll take h height. Then take this side 2gh, and here g. This and this we can cancel down. H we get half meters. Right. Under gravity it moves upwards half. Then you can take the answer. Initially 3 meters. Again it moves 3 by 2 meters. Another half meters. Then height above the ground of A. Therefore height. Height going to be, first people 3 by 2 meters. Right. And then half meters under gravity. Initially it was at a height 3 meters above the ground. Then we get the answer, no? Here what do you get? 1.5, 3 by 2 is 1.5, 2, and this 5 meters, right? Total is 5 meters from the ground. Right. Next part. Work power energy question. Right. A motor car of mass 840 kilogram moves freely down along a road of inclination 120 is to 1. Motor car this way, right? Theta. People, here 120 is to 1 means sine theta is 1 over 120. That's the meaning. It means 120 is to 1 means when something is moving along this path 120 meters, its rise is 1. The vertical displacement it gets is 1. Then one's opposite side is 1 unit. The hypertenuse is 120. That is how we take sine theta is 1 over 120. Right. Now we are given there, it moves with steady velocity 20 kilometers per hour. Right. Then this is the car. This is the car, right? It moves this way. Given 20 kilometers per hour. Right. Now we are given its mass is 840 kilogram. 840 kilogram means 840 g sine theta is the force acting down along the plane. Okay, down along the plane. Right. Now resistance acts this direction. Suppose it is R. Suppose it is R. You know, when this car moves with constant velocity, people, right? When the car moves with constant velocity, no acceleration. No acceleration means down along the plane, the forces equal to up along the plane, the forces. Right, down along the plane, component of weight, 840 g sine theta we have, up along the resistance R. So in this case, we are given the engine of the car is not working. Freely moving, no. Freely moving means no force given to what? The car by the engine. No force given to the car by the engine. Freely moving is that. That means car moves down along the plane due to gravity. Then this 840 g sine theta should be equal to R. Therefore, R is equal to 840 g sine theta, mg sine theta, right? 840 g take as 10 sine theta 1 over 120. So this way you can cancel down. Simplifying this, we get this R. R comes as 70 newtons. 70 newtons, right? Next one asking this. Calculate resistance to the motion, that's fine. Find the power of the car if it maintains the same speed on horizontal road. Now this car moves on a horizontal road like this. Right. Car moves horizontal road. With what velocity? Same velocity, no? Right. Speed, same speed. 20 kilometers per hour. People, 20 kilometers per hour, we can convert to meters per second. Right. 20 kilometers per hour, we should multiply by 5 by 18 to convert this to meters per second. Okay. When we do this way, we get 50 upon 9 meters per second. 50 upon 9 meters per second. Then we'll convert them to SI units. 50 by 9 meters per second. Kilometers per hour, we can convert to meters per second, multiplying it by the factor 5 over 18. Now, the resistance we have to assume as before 70 Newton. Then here, people, we need this time a force. That force is given to the vehicle by the engine, right? You know, H equals FV is the relation between power of the car. This F is the tractive force, V is the velocity. Now, we need in this case, people, the asking power. Find the power. H only we need to find. Okay, right. First of all, people, we know again when the car moves uniform velocity, this one again no what? No acceleration. When it maintains uniform velocity, no acceleration. No acceleration means the forces, resultant force acting on the car should be 0. So therefore, here also we can say F should be equal to 70. F should be equal to 70. Then we need to find H, no? H can be calculated. Therefore, H equals 70 into V. It is 50 over 9. Then we get H in watts. Then what do you get there? We get, it is 3500 by 9. 3500 by 9 watt. This is the required power of the car. Right. Question number 9 next. Right. There you are given question number 9. Yes, two smooth spheres P and Q. Mass 2m, 3m. P here, Q here, 2m, 3m, moving towards each other with velocity 7u and 3u. Right. Collide directly if the coefficient of distribution between the spheres is C, show that the impulsive force at the impact is this. All right. Impulsive force at the impact. At the moment of the collision, people. This is the equal and opposite impulsive forces act. I and I. Then after the collision, suppose they begin to move with velocities v1 and v2. This is P, this is Q, 2m, 3m. Okay, right. Now, first we can apply conservation of linear momentum rightward after the impact 2m v1, 3m v2 is the total momentum before 2m into 7u minus 3m into 3u. mu can cancel down. 2v1 plus 3v2 is equal to here 14, here 9, 5 u. We get number 1. Secondly, we apply Newton's law of restitution this way. It says minus e times relative velocity before impact. To find the relative velocity, you know, people, one particle we have to stop before and after impact. We'll stop this q. Before, to stop that, we have to put 3u rightward. Same 3u to right, we apply on this 7u, 3u, 10u. Then here we get minus 10 eu. After impact also, we have to stop people q. Then we have to apply v2 leftward on this v2 leftward. Then this p will have rightward v2 leftward, rightward v1 leftward v2. Then resultant velocity to the rightward of p is v1 minus v2. Because we have to take the rightward velocity as positive, because NLR we apply rightward. This number 2. If by simplifying this, right, we can take, we need to find, yes, we are given there, people, this way, if the SPF P is brought to rest after the collision, find the value of V. All right, both answers we can find if you find this V1, right. So then what we do is this 1 plus this 1 is added, multiplying second one by 3. Then here we get minus 3v2, no? This and this will be 0. 2v1, 3v1, 5v1 coming. Then here 5eu, 5u, and this should be multiplied by 3 minus 30e2. Then we can cancel down by 5. We get v1. It's u1 minus 6e. This way, yeah? Right. Now, asking to find the impulse at the impact. Impulsive force I. So this I can apply I equals delta mv. We can apply I equals delta mv. Right. I means impulsive force. I take this P. When I consider the sphere P, its mass is 2m. It was moving with velocity 7u just before the impact. At the impact, impulse force I acting leftward here. After that, it moves with velocity v1. Now, if I apply I equals delta mv, right, rightward direction, okay, I acts leftward, therefore it should be minus I. Delta mv, change in momentum. Change in momentum, we can find final momentum minus initial momentum. Here, final means after impact. After impact, momentum is 2mv1, right, minus before impact 2m7u. Okay. Then I can write here, people, I multiply both sides by minus sign. Then there we get 14 mu minus 2m v1. v1 is this. u times 1 minus 6e. Correct, no? Right. Then we get the answer here. We can take 2m out. 2mu we can take out. Here 2mu we get 7 here. 2mu when you take out, minus 1 plus 6e. Then here we get 7 minus 1 is 6. That 6 we can take out. With this 2, 12 mu 1 plus e we get. Right. Now, next one asking what, people? Next one asking, if the sphere P is brought to rest after the collision, find E. That means after collision, P is brought to rest, means V1 should be 0. V1 0. V1 0. V1 is this. 2 times 1 minus 6e should be equal to 0. That gives 1 minus 6 equals 0 equals 1 over 6. Equals 1 over 6. This way we can take that. Right. The last question, number 10. Last question number 10 will take. Right, we are given ABC is an isosceles triangle with B equals C. B equals C. Right. Okay. Now, BC vector A, BA vector simple B. Show that AD perpendicular to BC, where D is the midpoint of BC. Right. Okay. This in vectors only we have to show this. Right. Okay, I erase this now. ABC is an isosceles triangle, right? B angle and C angle equal, right? This will draw. A, B, C. And there you again BC vector is A. BC vector is A. This is A. And B angle, C angle equal. This angle and this angle being equal. Then you know this side and this side should also be equal. And BA vector is given as simple B. Right. So that AD perpendicular to BC, where D is the midpoint of BC. This is the midpoint D. These two are equal. Now we need to show AD. We need to show AD perpendicular to this BC. Right. Right. Now I can write first thing. I'll take this angle as theta. Then this also theta. I can write the CA vector. CA vector I can write people CB plus BA. CB plus BA. That means B minus A, no? Right? Then CA length is what? CA length means CA vector modulus is CA length. CA vector is B minus A, no? Then B minus A modulus is CA length. But AB length is equal to B modulus. Therefore, what can say? CA and AB equal, no? CA and AB equal, no? Isosceles triangle, no? Therefore, this modulus and this modulus must be equal. B minus A modulus should be equal to mod B. This we have. Right. Now, dA vector will find, or AD vector. dA vector will find. dA vector. dA vector going to be dB plus BA. dB means minus A by 2. BA means B. B minus A by 2. We get dA like this. Right. Right. Now, we can take this way. People, now I can take A dot B. This A dot B I can take. Now, A dot B, what is that? A modulus, B modulus, cos theta. Then subject cos theta. A dot B divided by mod A, mod B. Okay. Next one we can take this dot product between CA, CB. CA dot CA means this, CB. Right? CA, CB. What do you get there? CA, it is, there you get people yes, here CA means minus A, CA, right? CB, there we get CA, we get B minus C, wait. We take CB dot CA. Right. We write this one, people, how? CB modulus into CA modulus. Angle between them is theta, no? Cos theta. CB is minus A dot CA. CA we found B minus A is equal to CB vector, mean this vector, no? It is minus A modulus. Right. People, CA modulus mean CA length, this one. But we proved that one is equal to B, not B. Cos theta. We got like this, huh? Then we can write A minus A dot B, remove the bracket by using the distributive law, A dot B minus A dot A. Right. Minus A mod means A. Mod A, mod B, cos theta. Right now. Then we can take, people, here also cos theta subject. Cos theta we get minus A dot B minus A dot A, I can write as mod A square divided by mod A mod B. This is cos theta. Right. Now we have two expressions for cos theta here. Look at this. This is cos theta, this is also cos theta. We can equate them. Therefore, here we get A dot B divided by mod A mod B is equal to, here, minus A dot B mod A squared divided by mod A mod B. These two you can cancel now. Take this to this side, people. That will be plus A dot B plus A dot B. What is that? 2 times A dot B equals, here what do you get? Mod A square. Okay. Now we'll take, we need to prove this AD perpendicular to BC, no? To prove that the dA vector dot BC vector, the dot product between the two vectors dA and BC, we have to show 0. Right. dA vector we found. Right. Now we'll write dA vector. Now dA vector, this vector, dot BC vector. What is that? dA vector means B minus A by 2 into BC vector. BC vector is simple A vector. Now I can use the distributive law, B dot A minus half A dot A. B dot A I can write, people, A dot B minus half. A dot A means mod A squared. But now you can write for A dot B here. What is that? Half mod A squared. A dot B we can substitute from there, half mod A squared minus half mod A squared. This right hand side is 0. Dot product is 0. Dot product 0 means vectors are perpendicular. Therefore, dA vector perpendicular to BC vector, hence dA perpendicular to BC. Hence dA perpendicular to BC. Right? This is how we take that right answer. Okay, no?